Hello, in this lecture we'll find out the values of line segments X and Y. In the drawing we have a square DBEF that is inside the right triangle ABC. We know that one side of this square is equal to 1 unit, that is to say dB equals to 1 unit, BF equals to 1 unit, and also all the DE also equals to 1 unit, and EF also equals to 1 unit. And we also know that the hypotenuse AC of the right triangle ABC equals to 3 units, and we want to find out the values of line segment FC that is actually X, and the value of line segment AD that is actually equals to Y. Okay, so first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF, in square DBEF. We know that side DE is parallel to side BF of the square, and we also know that BC is one side of the right triangle ABC. So BC is one side of triangle ABC must be a straight line. So BC is a straight line, BC is a straight line, line segment BC is a straight line, or side BC is absolutely a straight line. And we know that part of the straight line BC, that is to say BF, is parallel to DE. So because of the fact that part of the straight line BC is parallel to DE, that is to say BF, that is part of BC, is parallel to DE, therefore BC will be also parallel to DE. Because of the fact that if part of a straight line is parallel to other straight line, then the straight line itself will be also parallel to that line, that is to say BC will be also parallel to DE. So BC will be also parallel to DE because of the fact that part of it is parallel to DE, therefore the straight line itself will be also parallel to the straight line DE. And so BC is parallel to DE, and we have the rule number 1, that states that corresponding angles between parallel lines are equal to each other. I write it down. According to rule number 1, corresponding angles between parallel lines are equal to each other. Okay, so I repeat on rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. So we have those two angles, they are defined as corresponding angles. That is to say, angles AED and angle EFC are two corresponding angles, and they are located between the parallel lines DE and BC. Therefore, according to rule number 1, they are equal to each other. So we can write down that angle DEA equals to angle FCE and those two angles are equal to each other according to rule number 1 because of the fact that they are located between the parallel lines DE and BC, therefore they are equal to each other. So angle DEA equals to angle FCE according to rule number 1. So if we define angle DEA as theta, so if this angle equals to theta, then this angle will be also equal to theta. Here you can see if angle DEA equals to theta, from this equation we will derive that angle FCE also equals to theta. So those two angles, they are both equal to theta, and if we focus on the right triangle, triangle ADE, on the right triangle, triangle ADE, then tangents theta, in this right triangle, tangents theta equals to AD over AE, I repeat again, in the right triangle, triangle ADE, we know that tangents theta equals to AD over AE, but AD equals to Y according to what is given us in the question, and AE equals to 1 because it is one side of the square DBFE and all of its sides are equal to 1. So in conclusion, we actually found out that in triangle ADE, tangents theta equals to Y. Okay, according to equation number 1, in triangle ADE, tangents theta equals to Y. In the next step, we'll focus on triangle EFC. On triangle EFC, tangents theta equals to EF over FC. I repeat again. In the right triangle FEC, we know that tangent theta equals to EF over FC. But EF equals to 1 because it is one side of square ABCD, and FC equals to X according to what is given us in the question. So in conclusion, according to question number 2, in the right triangle EFC, tangent theta equals to 1 over X. I will repeat again, according to equation number 1, in the right triangle EFC, tangent theta equals to 1 over X. 1 over X. So we have two different expressions for tangent theta. We create the third equation that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Okay, according to equation number 3, tangent theta according to equation number 1 equals to tangent theta according to equation number 2. That is to say, tangent theta according to equation number 1 equals to y, and tangent theta according to equation number 2 equals to 1 over x. So we found out that according to equation number 1, y equals to 1 over x. And if we multiply equation number 3 by x, we will get that y times x equals to 1. What does this equation number 3 means? It means that x and y are two inverse numbers. X is the inverse number of y, and y is the inverse number of x. For example, 5 is the inverse number of 1 over 5, and 1 over 5 is the inverse number of 5 because of the fact that if you multiply those two numbers each by one, each by the other, then you will get 1. So x and y are two inverse numbers, or two numbers that they are inverse to each other. Okay, so in the next step, we will focus on the right triangle ABC. On the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is AC square. AC square equals to AB square plus BC square. I'll repeat again. In the right triangle ABC, according to the Pythagoras theorem, PT is a regression for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AB square plus BC square, according to equation number 4. So AC equals to 3 units. It is given us in the question. So AC square will be equal to 3 square. 3 square is 9. And it equals to AB square. AB is y plus 1. So AB square will be equal to y plus 1 square plus BC square. BC equals to x plus 1, so BC square will be equal to x plus 1 square. So in conclusion, we got that according to equation number 4, 9 equals to 9 equals to y plus 1 square plus x plus 1 square. Here we will open the brackets in this side of equation number 4, and we will get that according to equation number 4, 9 equals to y plus 1 square is y square plus 1 plus 2y plus x plus 1 square, x plus 1 square equals to x square plus 1 plus 2x. But according to equation number 3, we found out that y equals to 1 over x, so we will substitute y by 1 over x. And we will get that according to equation number 4, 9 equals to y square. Y is 1 over x, so y square will be equal to 1 over x square plus 1 plus 2y. 2y is 2 times 2 over x plus x squared plus 1 plus 2x. Here we will organize the expressions here, and we will get that according to equation number 4, x squared plus 1 over x squared, 1 plus 1 is 2, plus 2 plus 2x plus 2 over x equals to 9. We know that x squared plus 1 over x plus 2 equals to x plus 1 over x squared. So I write it down. X plus 1 over x squared plus, here we will take out as a common factor, we will take 2 as a common factor out of these two expressions, and we will get that it is 2 here inside the brackets. We will have x, and from this expression we will have 1 over x, and that equals to 9. Here we subtract 9 from this equation, equation number 4, and we will get that according to equation number 4, x plus 1 over x squared plus 2 times x plus 1 over x minus 9 equals to 0. So here we will define t as equals to x plus 1 over x. Again, t is defined as x plus 1 over x. And then we will substitute x plus 1 over x in this equation, equation number 4, by t. And we will get that according to equation number 4, x plus 1 over x squared will be equal to t squared, plus 2 times x plus 1 over x is 2t, minus 9 equals to 0. So here we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. If a, b, and c in this general quadratic equation are the coefficients of this quadratic equation, as e and x is the variable that we are looking for, and we find out the value of x according to a special formula, that x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So in our specific quadratic equation, t squared plus 2t minus 9 equals to 0, the variable that we are looking for is t, so x equals to t, and a equals to 1, b equals to 2, and c equals to minus 9. So here we will put the data inside this equation in order to find out the value of t in our specific quadratic equation, and we will get that x equals to t, so t equals to minus b, b is 2, so minus b is minus 2, plus minus square root of b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, 4 times 1 is 4, times c is minus 9, so minus 4 times minus 9 is plus 36 over 2a. 2a is 1, so 2a is 2 times 1, 2 times 1 is 2. So in conclusion, we found out that t equals to minus 2 plus minus 4 plus 36 is 40 over 2. But we know that 40 is 4 times 10. 40 is 4 times 10, and the square root of 4 is 2. So we can write down that here t equals to minus 2 plus minus, the square root of 4 is 2, so it is 2, and inside the brackets, inside the root, we have only 10 over 2. So we actually found out that t equals to minus 2 plus minus 2 times square root of 10 over 2. Here 2 over 2 is 1, so 2 will get cancelled. So I write it down. We found out that t equals to minus 2 over 2 is minus 1 plus minus square root of 10. So here we have two possible solutions. The first solution to the quadratic equation is that t equals to minus 1 plus square root of 10 and the second solution is t equals to minus 1 minus square root of 10. Okay, so according to our definition, t equals to x plus 1 over x. So we write it down, t equals to x plus 1 over x. X is length, as x is length, therefore it must be a positive number. Therefore x plus 1 over x is a positive number. While minus 1 minus square root of 10 is a negative number. And we know that a positive number can never be equal to a negative number. Therefore, this possibility will be cancelled. This is not correct answer, and we left only with the answer that t equals to 1 minus 1 plus square root of 10. T is actually x plus 1 over x according to our definition, and it equals to minus 1 plus square root of 10. And here we will multiply x by x, and then we will divide it by x in order to have a common factor with this expression, and we will get that x squared plus 1 over x equals to minus 1 plus square root of 10. So here we will multiply this equation by x, and we will get that x squared plus 1 equals to x times square root of 10 minus 1. So here we will subtract x times square root of 10 minus 1 from this equation, and we will get a quadratic equation. The quadratic equation that we will get will be x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So here we got a quadratic equation. In this quadratic equation, a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. The solution of a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So the solution for our specific quadratic equation will be as follows: x equals to minus b. Here minus and minus will be plus, so it will be square root of 10 minus 1 plus minus b square will be square root of 10 minus 1 square minus 4 times a times c. A and c is 1, so minus 4 times a times c will be minus 4, will be equal to minus 4 over 2a. A is 1, so 2a is 2 times 1 is 2. So actually we got here that x equals to the square root of 10 minus 1 plus minus square root of, here we have square root of 10 minus 1 square, so it will be 10 plus 1 minus 2 times square root of 10 times 1 is, so times 1 will be the same number, so we will leave it as it is, minus 4 over 2. So here we got actually that x equals to square root of 10 minus 1 plus minus square 10 plus 1 is 11, 11 minus 4 is 7, so it is actually 7 minus 2 times square root of 10 over 2. So we actually got here two solutions for x. X equals to the square root of 10 minus 1 plus minus square root of 7 minus 2 times square root of 10. So what is the value of 7 minus 2 times square root of 10? Here 7 is 5 plus 2, so I write it down, and minus 2 square root of 10 is square root of 5 times square root of 2, and 5 is square root of 5 square, two is square root of 2 square, minus 2 times square root of 5 times square root of 2. Actually, this expression equals to square root of 5 plus square root of 2 square. Again, according to the algebraic identity, that a plus a minus b square is minus a minus b square equals to a square plus b square minus 2 times ab. So it is square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2 equals to square root of 5 minus square root of 2 square. So we can substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square. So we'll do it now, and we will get that x equals to square root of 10 minus 1 plus minus square square root of, and instead of 7 minus 2 times square root of 10, we will write down square root of 5 square minus square root of 2 square, square root of 5 minus square root of 2 square, all divided by 2, of course. Here it is divided by 2. So here we have square and we have root, so the square cancels the root, and we left only with square root of 5 minus square root of 2. So I write it down. We got that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2, because of the fact that the square cancels the root and we left only with square root of 5 minus square root of 2, all divided by 2. So here we will have two solutions possible. The first solution will be x equals to square root of 10 minus 1 plus square root of 5 minus square root of 2. This is the first solution. And the second solution, all divided by 2, of course. And the second solution that is possible is that x equals to square root of 10 minus 1 minus square root of 5 plus square root of 2, all divided by 2. This is the second solution that is possible for the quadratic equation for x. So according to the first solution, here we will get that x equals to, we will substitute square root of 10 by square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. Here we will take square root of 5, square root of 5 as a common factor, and we will get that x equals to square root of 5 is taken as a common factor. Inside the brackets we will have square root of 2 plus 1 plus 1, and here we will have minus 1 minus square root of 2, so we take from those two expressions minus 1 as a common factor, and inside the brackets we will have 1 by square root of 2, square root of 2 plus 1, all divided by 2. Here we will take square root of 2 plus 1 as a common factor, and we will get that x equals to square root of 2 plus 1 is a common factor. Inside the brackets we will have square root of 5 minus 1 over 2. So the first solution that for x is x equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. And the second solution that is possible, here x equals to, so square root of 10 minus 1 minus square root of 5 plus square root of 2 over 2. So x, here we will substitute square root of 10 by square root of 5 times square root of 2 minus square root of 5 plus square root of 2 minus 1, all divided by 2. So here we take square root of 5 as a common factor from this side of the equation, and we get that x equals to square root of 5 is taken as a common factor. So inside the brackets we will have square root of 2 minus 1 plus square square root of 2 minus 1 over 2. Here we'll take square root of 2 minus 1 as a common factor, and we will get that x equals to square root of 2 minus 1 is a common factor, and inside the brackets we will have square root of 5 plus 1 over 2. So we found out two solutions for the quadratic equation x1 and x2. We will multiply the two solutions each by other, and we will find out that x times x, it is actually will be equal x times x. It is actually x1 and x2 because they are the two solutions for the quadratic equation. So actually x times x, or x1 times x2, will be equal to square root of 2 plus 1 times square root of 5 minus 1 over 2 times x2, that is actually square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. So actually we multiplied here the two solutions for the quadratic equation, x1 times x2, or x times x, and here we will have algebraic expression that square root of 2 plus 1 times square root of 2 minus 1 is very similar to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. And here a equals to square root of 2, so a squared is 2. Square root of 2 is 2 minus b squared. Here b is 1, so b squared is 1, because 1 squared is 1, so it is minus b squared is minus 1. And there, square root of 5 minus 1 times square root of 5 plus 1, it is actually very similar to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. Here a equals to square root of 5, so square root of 5 squared, that is actually a squared is 5 minus b squared. B equals to 1, so b squared is 1 squared is 1, so minus b squared is minus 1, so it is actually 2 minus 1 times 5 minus 1 over 2 times 2 is 4, 2 times 1 is 1, 5 minus 1 is 4 over 4. 1 times 4 is 4, 4 over 4 is 1. So we actually found out that the multiplication of the two solutions of the quadratic equation gives us 1. It means that the two solutions are inverse to each other. That is to say, if one solution is, for example, is 5, then the other one will be 1 over 5. Okay? And according to equation number 3, we have already found out that x times y equals to 1. That is to say, x and y are also opposite to each other. As you can see here, y equals to 1 over x. So, and we know that when we multiply the two solutions, when we multiply x by y, we get 1. So the first solution will be x1, y1, and we know that x1 times y1 must be equal to 1. That is to say, the first solution, x1, is actually square root of 2 plus 1 times square root of 5 minus 1 over 2. That is x1, and y1 must be equal to square root of 2 minus 1 times square root of 5 plus 1 over 2, because of the fact that if we multiply x1 by y1, we will get 1. Okay? Exactly as we found out here, that x1 times x2 equals to 1. So therefore, if x1 equals to this expression, then y1 must be equal to this expression, in order that the multiplication of x1 by y1 will get us 1. According to equation number 3, the multiplication of x1 by y1 must be equal to 1, because of the fact that x times y equals to 1. Okay, so those two expressions, x1 times y1, will give us 1. So this will be the first pair of solutions that is possible for x and y. And the second pair of solution for x and y will be x2, y2. So x2 will be equal to square root of 2 minus 1 times square root of 5 plus 1 over 2. This will be x2, and y2 will be equal, it will be the inverse number of this number. And what is the inverse number of this number? It will be square root of 2 plus 1 times square root of 5 minus 1, exactly this expression. Square root of 5 minus 1 over 2. So those two numbers, x2 and y2, are two inverse numbers. x2 is the inverse number of y2, and y2 is the inverse numbers of x2. Therefore, if we multiply x2 by y2, we will get 1, exactly as equation number 3 demands, that x times y must be equal to 1. So x1 times y1 will give us 1, exactly according to equation number 3, and x2 times y2 will give us also 1, exactly according to equation number 3, exactly like the demand according to equation number 3, that the multiplications of the two solutions of x by y will give us 1. Okay, so those are the two solutions for x and y. This x1 and y1 are the first pair, and the second pair of the solutions for x and y is x2 and y2. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the value of x and y here square DEBF that is inside the right triangle, triangle ABC. We know that one side of square DEFB equals to 1 unit, and we also know that the hypotenuse of the right triangle, triangle ABC equals to 3 units, and we want to find out the values of line segment FC, that is X, and line segment AD, that is Y. So first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. Okay, again, DE is parallel to BF, and BC, side BC is one side of triangle, the right triangle, triangle ABC. Therefore, BC it is absolutely a straight line. Okay? So, and what is BF? BF is part of BC. BF is part of BC. And we know that BF is parallel to DE. So, if part of BC, that is a straight line, is parallel to DE, then BC itself, that is a straight line, must be also parallel to DE, because of the fact that if part of straight line is parallel to another straight line, then the straight line itself must be also parallel to that line. Therefore, we will conclude that BC is parallel to DE. And we also have rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. Those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. We know that DE is parallel to BC. Therefore, according to rule number 1, they are equal to each other. That is to say, angle ADE equals to angle FCE, according to rule number 1. So, if we define angle ADE as theta, then from this equation we will get that angle FCE also equals to theta. So, those two angles are both equal to theta. And then in triangle ADE, we also know that AB is a straight line. AB is a straight line because it is one side of the right triangle, triangle ABC. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line AB at point D, that the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at point D of this, at this side? We have this angle that equals to 90 degrees plus this angle that we define as angle X. So 90 degrees plus X must be equal to 180 degrees. And here 90 degrees plus X must be equal to 180 degrees. So this angle is angle X. So X plus 90 degrees must be equal to 180 degrees according to the rule that I mentioned. If we subtract 90 degrees from this equation, we will get that angle X equals to 90 degrees. Okay, so angle X equals to 90 degrees. It is a right angle. Therefore, triangle ADE is a right triangle. Triangle ADE is a right triangle. This angle equals to 90 degrees. Likewise, we know that BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. Okay, BC is a straight line. And we know that the sum of the angles on one side of a straight line must be equal to 180 degrees. So if we focus on the upper side of the straight line BC, then the sum of the angles at point F must be equal to 180 degrees. So if we define angle FEC as Y, then which angles we have at point F at the upper side of BC? We have here 90 degrees plus this angle that is angle Y. The total of the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of a straight line must be equal to 180 degrees. Here we will subtract 90 degrees from this equation and we will get that angle Y equals to 180 degrees minus 90 degrees equals to 90 degrees. So we found out that angle Y equals to 90 degrees. That is to say this is a right angle, so we substitute angle Y by right angle. And because of the fact that angle EFC equals to 90 degrees, it means that triangle EFC is a right angle. So we found out that triangle ADE is a right triangle and triangle EFC also is a right triangle. Okay, so now we will focus on the right triangle, triangle ADE, this right triangle. In this right triangle, we know that tangent theta equals to AD over DE. In the right triangle, triangle ADE, we know that tangent theta equals to AD over AE. But AD equals to Y. D equals to 1. So in conclusion, we found out that tangent theta equals to Y. Then in the right triangle, triangle EFC, we also know that tangent theta equals to EF over FC. Tangent theta equals to EF over FC. But EF equals to 1. FC equals to X, according to what is given in the question. So in conclusion, we found out that tangent theta, according to equation number 2 in triangle EFC, equals to 1 over X. So we have two different expressions for tangent theta. Therefore, we can create equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. And tangent theta according to equation number 1 is Y, and it must be equal to tangent theta according to equation number 2, that is 1 over X. So we got equation number 3 that states that Y equals to 1 over X, and if we multiply equation number 3 by X, we will get that Y times X equals to 3. What does it mean that Y times X equals to 1? It means that Y is the inverse number of X and X is the inverse number of Y. That is to say, if Y equals to 5, then X must be equal to 1 over 5. Okay, X and Y are two inverse numbers. Okay, Then we focused on the right triangle, triangle ABC. On the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. AC equals to 3 units, according to what is given us in the question. So AC square is 3 squares. 3 square is 9. AB square, AB equals to y plus 1. So AB square will be equal to y plus 1 square and plus BC square. BC is x plus 1. So BC square will be equal to x plus 1 square. So in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 square plus x plus 1 square. Here we open the brackets on this side of equation number 4. And we got that 9 equals to y plus 1 square. Y plus 1 square equals to y square plus 1 plus 2y plus x plus 1 square. X plus 1 square equals to x square plus 1 plus 2x. And according to question number 3, we have already found out that y equals to 1 over x. So we can substitute y by 1 over x. We did it, and we got that 9 equals to y square. Y square is 1 over x square plus 1 plus 2y, and y is 1 over x, so it is actually 2 over x plus x square plus 1 plus 2x. Here we arrange the numbers in such an order that here we get x square plus 1 over x square plus 1, it is 1 unit, plus 2x plus 2 over x equals to 9. And inside the brackets, we have the expression of x plus 1 over x square. And here we took a common factor of 2 from these two expressions. Inside the brackets, we got x plus 1 over x equals to 9. Here we subtracted 9 from this expression, equation number 4, and we found out that x plus 1 over x squared plus 2 times x plus 1 over x minus 9 equals to 0. Then we define t as x plus 1 over x, and we substituted x plus 1 over x in equation number 4 by t. So we got t squared plus 2t minus 9 equals to 0. So we got here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. And here the solution, actually a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. A, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So in our specific quadratic equation, we know that the variable that we are looking for is t, so x equals to t, a equals to 1, b equals to 2, and c equals to minus 9. So we put that data inside the equation for x, that in our specific equation x is equal to t, and we got that t equals to minus b. B is 2, so minus b is minus 2, plus minus b squared. B squared is 2 squared, 2 squared is 4, minus 4 times a times c. 4 times a is 1, so 4 times minus 4 times 1 is minus 4. Minus 4 times minus 9 is plus 36. So inside the root we have 4 plus 36 over 2a. A is 1, so 2a is 2 times 1. 2 times 1 is 2. So in conclusion we got that t equals to minus 2 plus minus square root of 4 plus 36 over 2, 4 plus 36 is 40. So in conclusion, we got that t equals to 2 plus minus square root of 40 over 2. And 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that t equals to minus 2 plus minus 2 times square root of 10 over 2. Here we divided this equation by 2. 2 over 2 is, sorry, minus 2 over 2 is minus 1. Plus minus 2 over 2 is 1. So in conclusion, we got that t equals to minus 1 plus minus square root of 10. So t equals to minus 1 plus minus square root. So we have here two solutions that are possible. The first solution is t equals to minus 1 plus square root of 10. And the second solution is t equals to minus 1 minus square root of 10. And according to the second solution, t equals to minus 1 minus square root of 10. Minus 1 minus square root of 10 is a negative number, and t equals to x plus 1 over x according to our definition, and x is a length of a side of a triangle, therefore it must be a positive number. So this expression x plus 1 over x must be a positive number, while this expression minus 1 minus square root of 10 is a negative number, and a positive number can never be equal to a negative number. Therefore this solution is incorrect solution. We cancel this solution and we left only with the solution that equals to minus 1 plus square root of 10. And according to our definition, t is x plus 1 over x, that equals to minus 1 plus square root of 10. So here we multiplied x by x and then we divided x by x, and we got that x squared plus 1 over x equals to minus 1 plus square root of 10. Here we multiplied this equation by x and we got that x squared plus 1 equals to x times square root of 10 minus 1. So here we substituted x times square root of 10 minus 1, and we got the quadratic equation that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. Here a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the solution to the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac times 2a. So we put the data inside this general solution for x, and we got that x equals to minus b. Here we have minus and minus is plus, so in conclusion we found out that minus b is square root of 10 minus 1 plus minus b squared is square root of 10 minus 1 square minus 4 times ac. A is 1, c is 1, so ac is 1 times 1 times 4. 4 times 1 times 1 is 4. And here we have inside the root square root of 10 minus 1 square. It is actually a minus b square is a square plus b square minus 2 times ab, so it is square root of 10 square, that is 10, plus b square is 1 square, 1 square is 1, minus 2 times square root of 10 times 1, so it is minus 2 times square root of 10 minus 4. So here all divided by 2, 10 plus 1 is 11, 11 minus 4 is 7. So in conclusion, inside the root we have 7 minus 2 times square root of 10. Okay, inside the root we left with square root of 10 minus 1 plus minus square root of 7 minus 2 times square root of 10. So all divided by 2. So what is the value of the expression inside the root? Inside the root we have 7 minus 2 times square root of 10. And what the value of this expression? 7 is 5 plus 2, so it is 5 plus 2 minus 2 times square root, and square root of 10 is square root of 5 times square root of 2. So in conclusion we got that this expression equals to 5 plus 2 minus 2 times square root of 5 times square root of 2. And 5 is actually square root of 5 square, and 2 is square root of 2 square. So in conclusion we got that this expression equals to square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2. And this expression is very similar to the expression that a squared plus b squared minus 2ab equals to a minus b squared. So we can substitute this expression by a minus b squared when a equals to square root of 5 and b equals to square root of 2. So we did it, and we got that square root of 5 minus square root of 2 square equals to this expression, and all divided by 2 of course. And we got that x equals to here square root of 10 minus 1 plus minus here. So inside the root we substituted 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square, because they are equal to each other. And we have here square and root. The square cancels the root, and we left only with square root of 5 minus square root of 2. So in conclusion we got that x equals to square root of 10 minus 1 plus minus square root of 5 over minus square root of 2 over 2. So we have here two solutions that are possible. The first solution is that x equals to square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. And the second solution is that x equals to square root of 10 minus 1 minus square root of 5 plus square root of 2. So here, if we continue with the first solution, we will get that x equals to, we substitute the square root of 10 by square root of 5 times square root of 2. And here we have minus 1 plus square root of 2 minus square root of 5 minus square root of 2 over 2. Here we took square root of 5 as a common factor. So square root of 5 is a common factor. Inside the brackets we will get square root of 2 plus 1 minus square root of 2 plus 1. Here we took square root of 2 plus 1 as a common factor. So square root of 2 plus 1 is a common factor, and inside the brackets we have here square root of 5 minus 1 over 2. So the first solution is x equals to square root, for x it is actually x1 equals to square root of 2 plus 1 times square root of 5 plus 1 over 2. And the second solution for x of the quadratic equation is x equals to square root of 10 minus 1 minus square root of 5 plus square root of 2. Here we substitute the square root of 10 by square root of 5 times square root of 2. And in conclusion we found out that x equals to square root of 5 times square root of 2 minus square root of 5 plus square root of 2 minus 1, all divided by 2. Here we took square root of 5 as a common factor from these two expressions, and inside the brackets we have square root of 2 minus 1 plus square root of 2 minus 1. Here we took square root of 2 minus 1 as a common factor, and we found out that inside the brackets we will have square root of 5 plus 1 over 2. So the second solution for x, it is actually x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. So those are the two solutions for the quadratic equation for x. And then we multiply the two solutions for x each by other, and we got that x times x, it is actually equals to this expression, and the multiplication of those two expressions each by other will give us 1. Why? Because it is actually square root of 2 plus 1 times square root of 2 minus 1, it is very similar to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. A is square root of 2, so a squared is square root of 2 squared, that is 2, minus b squared is 1 square, 1 square is 1. So it is 2 minus 1, and then we have square root of 5 minus 1 times square root of 5 plus 1, and according to the algebraic identity that a plus b times a minus b equals to a square minus b square, we will get that here a is square root of 5, so a square is square root of 5 square root of 5 square is 5, minus b square, b is 1, so b square is 1 square, 1 square is 1, so it is minus b square, it is minus 1, so a square minus b square equals to a square, a plus b times a minus b equals to a square minus b square, and a square minus b square is 5 minus 1, all divided by 2 times 2, that is 4, 2 minus 1 is 1, 5 minus 1 is 4, 4 times 1 is 4, so 4 and 4 over 4 is 1. So in conclusion, the multiplication of x1 by x2 gives us 1. Therefore we can say that the two solutions are two numbers that are inverse to each other, and we also know that x and y are inverse to each other. X the inverse number of y, and y is the inverse number of x. So we know that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2, and y equals to 1 over x. Is the inverse numbers of x. And according to this multiplication, we know that x times x equals to 1, therefore we will multiply x1, that is actually square root of 2 plus 1 times square root of 5 minus 1 over 2 by this expression, and we will get 1, because x1 times y1 must give us 1 according to equation number 3, and x2 times y2 also must give us 1 according to equation number 3, and indeed we know that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, therefore y2 must be equal to square root of 2 plus 1 over square root of 5 minus 1 over 2, because of the fact that the multiplication of those two expressions will give us 1 exactly as equation number 3 demands. So we have two solutions for x and y. The first four solutions for x1 and y1 are those two expressions, and x2 and y2 are those two expressions, and that is the answer to the question. Okay, thank you very much.